welcome back to my YouTube channel. Today I am presenting here the Kernel SVM. My name is Tanvi Godke. Contents. Quickly walk through the structures of the presentation. The SVM. What is SVM? Limitations of linear SVM. The concepts of kernel functions and tricks, pros, applications and drawbacks. Next, go to the next slide. First one is the introduction to SVM. Explain the SVM is a supervised learning algorithm used for a classification and regression. Mention that it finds an optimal hyperplane to separate the classes, not its expensiveness for linearly separable data, but the limitations with the complex nonlinear parameters. Work for linearly separable data. Next slide is the problem with a linear SVM. So, the problem with a linear SVM is emphasize that real world data often is linearly separable. A simple line won't divide the data correctly. Introduce the idea of mapping data to a higher dimensional space. Need to map higher dimensional space. Go to the next slide. That is what is a kernel. Define a kernel as a function measuring similarity in high dimensional space. Highlight that kernels enables to SVM to work with nonlinear data without explicitly transforming it. It's a mathematical shortcut for dealing with example data structures. Next slide is a common kernel function. Introduce a key kernel types with their equations. A linear simple dot product. Polynomial kernel adds a flexibility with degree and constant. RBF kernel means the major similarity based on distance and most common. Next one is a sigmoid kernel. Sigmoid kernel is similar to activation functions in neural networks. Next slide is a kernel trick. Explain the kernel tricks. Avoids computing the actual coordinates in higher dimensions. Just computes the inner products using kernel functions. This makes SVM efficient even in complex space. Next one is the advantages of a kernel SVM. Handles a complex and nonlinear data effectively. Requires less memory. Flexible with a different kernel for different problems, and performs a well high dimensional feature space. Next is applications of kernel SVM. List practical applications: image and text classification, bioinformatics, cancer detection, handwriting recognition. Next slide is limitations. Kernel SVMs can be hard to turn. Kernel plus hyperparameters, computationally intensive on large data sets, and less interpretable compared to similar models. Go to the next slide for a conclusion. Conclusion of kernel SVM. Kernel SVM overcomes the linear limitations of a traditional SVMs. They map data impactfully to higher dimensions using kernels. When turned well, they are powerful for complex tasks. Thank you. Thank the audience for the attention.